ladies and gentlemen. It's Paul Smith, the newly incumbent chairman of the Internet SG. I deeply appreciate very much on behalf of the rest of the committee, everyone's attendance tonight. I think it's a fascinating session and an opportunity for us all to learn an awful lot. So without over talking, as is my nature, pleased and have the pleasure of introducing Clive and Alejandro to hopefully teach us a lot. And I deeply, deeply appreciate everyone's time. Over to yourself, Clive and Alejandro.
Great, thanks for having us here. Really appreciate it. Looking forward to it. So I'll share my slides. So hopefully you can see that. Tell me if you can't. Great. So yeah, I'm Clive Cox. I'm CTO of Seldon, and I have my colleague Alejandro Salcedo, who's engineering director. I'm sure you just want to say hello quickly, Alejandro.
Hello. Really looking forward to dive into what will be a very interesting and packed topic.
Cool, great. So the talk's in two parts. I'll be doing the first part more on the sort of technological aspects of machine learning deployment, and then we'll hand over to Alejandro to go more into the wider society and ethics aspects that this produces. So as just a starter, just as I'm not sure how many people are up to speed with machine learning, I just wanted to give a quick single intro slide. Obviously, this can't explain all aspects of machine learning. This is just the sort of most standard type of machine learning. So obviously this is supervised machine learning. There's other types, like online learning and reinforcement learning, which I won't go into, but this is probably the most common in industry. So generally you would have some data, which has some various set of features, and you've got labels that you want to predict. And you've done some labeling tasks, maybe it's images, you said this is a cat, this is a dog, etc. So you've got that data and you want to make a model from it that's going to generalize to new data that you haven't seen. So there's the interesting black box, which is the machine learning, what the old data scientists are doing to actually build their machine learning model. So your input would go in there, say an image or some text or something, some features, you get an output saying it's a cat or a dog. And then generally in supervised machine learning, which is the most common case that's been around, you then calculate, given the label and given the output the model did, some cost. So is it correct? Is it incorrect? Or how much is it incorrect or how much is it correct? And from that, you feed that information back into the model. And that's where obviously the interesting part of machine learning, the training algorithm, the learning happens. The model then changes some of its weights, some of its rules internally to try and make its output next time slightly better. And obviously in machine learning, you just repeat that process many times on a large amount of data. Usually you normally need a very large amount of data to make this work, to actually get this model to get better and better at predicting. And you hope that from that, it's going to generalize. So when you put it out into live or new data that you haven't got as part of your training set, it's then going to make interesting generalizations and make correct predictions. And obviously part of the actual deployment process is to actually deploy these models and then update them in future as you get more training data, probably from the model actually running live. So hopefully for those who are not sort of au fait with machine learning, that gives us a brief intro to roughly how machine learning works, especially in the most simple case of supervised machine learning. So in terms of the next stage is viewing the entire pipeline of machine learning from the different stages you go through from that data to actually deploying your model. And there's many different ways of viewing that pipeline, but this is like one taken from the Linux Foundation AI subgroup. And generally, this is quite a common way of viewing it. So there's sort of three different sort of rows, three levels you'd go through in the actual pipeline. The first would be the actual data preparation. This is when you've got some data that you want to do machine learning on. Normally, there's a lot of cleaning and working out particular features that would help your model to learn, and you do those transformations and change the data, do some engineering on those features, and then eventually you probably split up the data into a training set and a test set, so you can keep some data to one side that's going to be tested on to see if your model is actually doing some generalization on the data and doing something useful. That's this where you start, and a lot of work is done in this area to really get the data appropriate to actually build your model on. And obviously, you eventually need to make it so automated, so that as you get more data in the future, you can go through this process in an automated fashion to create new updates to your model to improve it in the future. The next stage is the part when you apply a particular algorithm, as we said on the last slide, particular machine learning algorithm, of which obviously there are many different types. When you're actually going to build that model, you're going to train it on that data. You're going to validate it against maybe the data you split out for testing purposes, and you might need it to train it at a very large scale to if you've got massive amounts of data, which is normally what you need in machine learning models. And there's obviously specialized techniques to train those models at a really high scale. So after that middle layer, you've got a particular model, great, you're ready to go. And then you go on to the final stage, which is the sort of topic for today, which is actually deploying and rolling out that model. So you're going to deploy it, you're going to serve it, then you want to monitor it, get logging and explainability, which we'll go into. And this is really what we're going to concentrate on today. And obviously the whole point of machine learning is it doesn't stop there, the whole pipeline. It then feeds back as you get more data from it being used live out there in the world. The data from that will feed back. You may have to relabel it, it will come back here, or come back into various parts of the pipeline to then be reanalyzed, retrained, retrain a new model, and you want to then push out that new model, hopefully a better model, to your customers. So that's the standard pipeline. You'll see many different variants of this, but this is the one, the way the LFAI are sort of showing it in their recent slides. So this is sort of the state, or a famous tweet that came out sort of 2 or so years ago from one person saying, the story of enterprise machine learning, it took me 3 weeks to develop the model. It's been more than 11 months and it's still not deployed. And it's caused obviously quite a big stir in the Azure community. So saying, you know, this is really the state, you know, we've got all these great data scientists doing this work, but actually getting it out there in to live production is actually the real sort of bottleneck, and that's causing a lot of delays. So one way you can view one aspect of this is that this is the sort of perception maybe that a lot of people have of machine learning, that most of the work is doing that, you know, core data scientists, your PhDs you've hired for your company to actually build this machine learning code, do all the exciting algorithms and stats and maths, and that's really all that's masses of code are out there. And then you've got all this other part that some of the steps I've talked about already, and they're just, okay, there's just little parts of the equation that you can add in, but this is really where you got to hire. But this is a sort of famous paper from 2015 written by some people at Google that was really saying that's not the case. Really, the machine learning code at Google, where each of these boxes is at Google how much code they have doing these different particular areas, and the actual machine learning code is a very, very small part of the overall code that's actually running to actually get you to the entire machine learning pipeline that we discussed. So really what you're seeing is that there's going to be a lot of technical debt if you're thinking, okay, I want to bring machine learning into my company, my organization. If I just think about it, it's all this is what I've got to need to do. Actually, you're going to realize there's actually a lot of stuff you're going to have to write to actually manage that machine learning live, do all the data collection, pushing out to serving, all the monitoring. And so if you're not careful, you're going to have a huge amount of technical debt in your company. And so this is why companies like ourselves, like Seldon, have been created to really focus on particular areas of that pipeline we discussed. So in Seldon, we focus on the serving infrastructure, the monitoring, and other aspects of this core part here of the actual pipeline. That's obviously what we're focusing on today. And there are other companies that have come up to focus on different parts of the pipeline and join together to create a full ML stack. So the idea is eventually you can get your PhD or your other people in your company or use standard models to do this work here, which is very particular to your company to make machine learning use in your company to make a difference. And then you can use best of breed tools around here to do some of this, take away some of this technical debt from your company. And this is sort of one of the real impetus is for Seldon when this came out in 2015 to really set our direction, what we wanted to do. Just to say also that it's a very active research area now. This is a workshop from this last year's ICML, which is one of the top machine learning conferences. And this was the first workshop that they brought out on the challenges in deploying and monitoring machine learning systems on a wide range of topics. So we actually had a couple of papers in here from myself on serverless inferencing on Kubernetes, and one of our data scientists on monitoring explainability of models in production. But it really shows there's a real deep interest in academia also now realizing that there's a lot of research that needs to be done in this area of actually deploying and so monitoring machine learning models, whereas before people were just thinking about interesting new ways to train models, interesting algorithms to create them, you know, that big black box that I showed. But now there's a sort of realization also in academia, there's a lot of research that needs to be fed in from experiences in so companies, when they put these models actually live, all the stuff to really get it working together. So thinking again, so if you think, okay, so how hard could it be? Really, you just need to get that model out there and just give it an API endpoint, and that's it. Isn't that all you really have to do? Well, actually, there's quite a lot of other stuff, and we're going to be diving into some of this, not all of this today, just because there's actually quite a lot that you really need to do to get your models out there. So obviously there's many different frameworks. As you said, there's different algorithms and frameworks that to actually build your machine learning models. So you need to serve those in an optimized way when you're running it in production. So obviously it's TensorFlow, XGBoost, Scikit-learn, and many other types, or even custom codes. We have many customers actually using Java code for their machine learning, or other types, C++, R, etc. And you want a sort of consistent way to actually deploy that. So it's simple to deploy all these different things that data scientists use. Because really what customers want is to really, for their organization, choose the best. Maybe it's TensorFlow model, maybe they have custom code, and they want to have a standard way of deploying that. So you've got to solve that. Also, when it's obviously deployed, you want to understand why is this model creating the predictions it does. And we'll go into a bit more about this. It's a really key, and it's going to be talked about a lot today in the talk. Are there outliers? Are the particular requests coming in that are outliers? I really should find out if those are happening, and we'll talk about that. Drift, has the input distribution changed? We'll talk about that today. Things like bias detection. Is my model actually biased, particularly certain protected groups? We won't talk about that so much today. That's also something that probably needs to be done at training time, but you also need to detect that at when you're actually running the model in production, because if there's drift, then your model might become biased for certain reasons. Is my model actually being attacked? There's obviously interesting cases, especially in sort of self-driving cars and stuff, where you can create sort of street signs that have a few sort of pixels change, and the model sort of detects it as a completely different type of sign, and you can actually create those signs up because of the way actually sort of machine learning models work. So you need to know whether your model is being attacked when it's actually being running as well. We won't go into that so much today, but that's another area you need to be aware of, especially in certain areas. A lot of the time, you might need to have custom pre and post transformers. So maybe your model takes an image, but that image needs to be turned into a set of features before it goes to the actual machine learning model. So you need like a pre-processing step. And maybe after the model gives back you some sort of probabilities, you might then need to turn that into something more humanly readable, or something that your actual end customer needs. So you need to be able to tie that in and tie it into the whole pipeline as well. So there's all that, and there's more here on the left. So there's, is the cost, how much am I, these models are sometimes expensive. You need GPUs or other systems which cost a lot of money when they're actually running. So you need to know whether my model is being used efficiently, and is it possible to scale it to zero? Maybe the model is only be used certain times of the day. Is it wise to have that model running all the time? So there are techniques to actually spot that and scale it down to zero, and then scale it up automatically. Stuff to do with health, how do you know your model is actually healthy when it's running? And obviously standard stuff to actually sort of introspect your model, check it's running okay. And then when you want to roll out the next version of the model your data science have created, is there a safe way to do that? Can you test changes on the traffic and push a little bit out to one model while you're pushing out the next model? All these need to be done in an automated way, especially for machine learning models. Even though this is quite a standard sort of DevOps task here, to actually push traffic to a small amount of traffic to a certain model and push it out to the main model when it's working okay. But for data science, there's more complex questions to be answered to know whether your new machine learning model is behaving correctly. We won't go into that so much today, but that's certainly a big topic, especially when you're going to be deploying, say, thousands of models. You can't have one person or a data scientist there on site checking every single model to check the input distribution is correct, etc. So you need to work out how you can do those data science tests on the model automatically as you push it out to production. And then as you push it out, you need to obviously decide how you're going to connect it to the actual so business users who want to call that model as part of their application. So are you going to expose it by different protocols, HTTP, gRPC, or are you using streaming aspects to actually talk to the model in a sort of more asynchronous way? So I think you can see there's quite a lot of steps just as part of the actual deploy and some monitoring part that really need to be solved, and it's quite a complex area. So one thing that we work on is in the cloud native domain. So I want to just go over some of the technology that's helped in that area to really help you deploy machine learning models. So as like a data scientist, you've written your model in a particular toolkit, be it TensorFlow, PyTorch, etc. And really the data scientist just wants to deploy, scale, and update it onto a cluster with the appropriate hardware on there to actually run their model. And fortunately, there's been a lot of things happening in the last sort of 8 to 10 years that really helped that. So you've got obviously Docker and the container runtime, so you can encapsulate all your dependencies into a single image, so you can do it so repeatably and push that out easily. You've got things like Kubernetes that come on, and we actually work in the cloud native world by deploying all our applications on Kubernetes. So you can manage many microservices of containers together, which talk together and scale up and down appropriately on, say, thousands of nodes. And the use of Kubernetes is great for that, to really scale up your machine learning. And then things built on top of Kubernetes like Istio for service meshes, network management, as you're obviously going to be calling over an API, can you get the security right for that? Can you handle the traffic? And Istio is a particular project that handles this. There's several others to help people really handle that sort of service mesh, as it's called, or connecting all your microservices together in an appropriate manner. And things like Knative, which we also use, which is a project to allow you to scale to zero, to allow you to scale your traffic down, scale your infrastructure down when your particular model is not being used, and scale it up on demand. And so we sit on top of this to give a sort of particular machine learning focused solution that uses all this stack. That means machine learning, data scientists don't need to understand some of these complexities of this underlying technology. As great as it is obviously a very complex world, and we want to give a focused solution. So that's really what you want, to really allow people to utilize some of this great technology that's coming out in this area. So I'm going to focus on several different areas of things you need to look at when you deploy machine learning models, particular drift and outliers and explanations, but also performance and metrics. We'll just dive into some of these into a little bit more detail. So in terms of performance, so first thing you need for that is you're going to need the labels. So obviously your model's there, it's running, it gives a prediction, and sometime in the future you're going to get back some feedback from the world to say whether that prediction was correct or not. That could happen very quickly. It could be like on a e-commerce site where your model is giving us a set of next steps for the customer, set of recommendations, and obviously if they don't click that, those recommendations, you can find out maybe within a few seconds whether the actual prediction has worked for this customer. But there could be other use cases which take a very long time, or you could be having some financial markets where it's going to be very, very quickly to know whether your model's predicted the next move in a financial market, or you could have a model working on, say, things like so medical images, which may take a long time. Did your prediction spotting whether there's certain tumors and stuff, was it correct? Well, that could take a certain amount of time to validate. So that means there's quite a different ways of actually handle that performance. But once you get those labels back, you can then bring out some metrics to really understand how your model's performing. But then again, you need to think about how those performance metrics are coming back. Are they very recent, as I said, or is it from predictions from a long time ago? And you need to collect them together in an appropriate manner to then give the appropriate metrics at the appropriate time. So there's quite a lot of complexity in that area in terms of actually sort of monitoring the performance of your models and how you do it over time. Then in terms of metrics, so in terms of actually understanding the actual data distribution of your model, there's a lot of different techniques here, but again, it's quite a complex area. Again, it's going to depend on the actual time periods and different sort of statistical techniques you use. And especially with features in machine learning models, the actual input features might not be so independent. There's certain aspects that make that more complex in terms of comparing some multivariate statistics over multiple features. So a lot of work here. Again, we won't go into that area in too much detail, but you need to be have quite different ways of viewing the input distribution of the data you're seeing live when you're actually running the model, and ways to really dive down, slice and dice it in appropriate ways to really get the detail you need to understand, again, that the model is behaving correctly. We'll dive down to some of the other aspects that we work on a lot at Seldon. One is outlier detection. So why is it you would want to have outlier detection? Well, one is that models normally don't generalize for data that is so outside their distribution that they've been trained on. So if you get an outlier coming in, normally the model might be so overconfident in its actual prediction, and so you don't want to actually use the prediction the model gave on that outlier in your actual business applications. You need to be careful if outliers coming, which means you need to spot it, but it's quite difficult for various reasons we'll go into. One is obviously that it's quite hard to get labeled data for outliers, because obviously that, so by definition, they're not data that's part of the training data. They're outside that. So you need particular techniques to try and spot that this particular input that's coming to the model is actually outside the sort of distribution that the model was trained on. There's various techniques for that, but it's definitely not an easy one. So we have a particular open source library called LFAI Detect, which you'll see the URL there. And that has various techniques for looking into outliers. And one of the things you can see here is that it's not like a sort of silver bullet. You have to choose a particular algorithm, which there are many here on the left, based on the type of data that your model is seeing. So there's some algorithms that work well on certain types of data. So you have tabular data that your model is receiving. It could be image data or time series data or maybe text data. And whether your model has sort of categorical features, you know, is it like rather than working in a range, it could be a certain set of particular values that this particular feature takes. And that actually makes it harder to spot outliers in that range. So you need to have particular outlier detection techniques that actually work on sort of categorical data. There are other aspects where you might want to look into whether you want to have an online outlier detection, so it's actually going to be learning as it sees the data and trying to predict outliers better. And also whether you want to get deep insight into the particular features. So up here you have an outlier detector that's going to spot whether, let's say here you've got some sort of corruption in this image, but you might want to dive down into particular features. And in the case of an image, that would be diving down into the particular pixels. So you're saying, yeah, these are actually the particular pixels, particular feature values. These are the outliers here of this part of the image. And that might be important to you, rather than just saying, okay, this is an outlier. You want to know why it's an outlier, to look at what this is actually this part of the image that has higher outlier scores. And again, it's only some of those algorithms will be able to give you that feature level. So there's a lot of trade-off there that you need to look into. The other side is another one that's very important is drift detection. So why would you want to have drift detection? Well, you want to know when your model performance is actually deteriorating. So if your model performance is going down, obviously you want to take the model offline, or you need to retrain it. So that's going to really depend on where the drift is coming from. Is it the input data that's drifting? You know, over time, is there sort of seasonality effects coming into play? That means the data that the model is seeing is not the same data that the model was actually trained on. You need to spot that, and then you need to obviously retrain the model and put out a new model that's based on the latest data. And that's obviously very key for these reasons. You know, your model performance is probably going to be dropping. But it could also be that the actual input distribution is only changing very slightly. So it's not really a big change there, but the actual distribution of the predictions is changing for some reason. So there's slight changes in the input distribution. Maybe different parts of the distribution is being seen, but the actual model starts to actually predict in a different way. And again, you need to spot that. Again, very similar to sort of outlier detection, that there's not a silver bullet. It's very hard, and it really depends. There's a lot of pre-processing for drift detection, especially for high dimensional data like images, to do it fast. And you're probably going to need to do some sort of dimensionality reduction to actually manage the drift detection. And normally, obviously, with drift detection, you're going to look over a large range. You're going to say over several thousand or sort of many thousands of samples coming into your model. You're going to have to then spot that the drift is happening now. So that there's also some sort of meta parameters or sort of hyperparameters you need to decide on as well. You know, how long am I going to view the drift is, how much of the past am I going to view in terms of whether I think a drift should be looked at. You know, it could be 5 minutes, or it could be several hours or several days of data that you think that drift is actually happening. So it really depends on your scenario and the type of model that you're actually running. So again, we have some algorithms in Alibi Detect, our open source library. Again, it depends on the type of data that your model is receiving as to whether those algorithms are applicable. And again, you have the same sort of levels of things you need to think about in terms of how you would deploy these drift detectors. There's examples here on the right in terms of like an image set. You've got the original image, and you've got different sorts of drift here for illustration. This is sort of what we use to test these things on. So you could blur the image, or you could have add some Gaussian noise, or change the brightness. And we see, so depending on the different sorts of drift, what types of algorithms spot these sort of drifts better or worse. So that's outlier and drift. Another thing that's very important to us is explaining models, and we'll come to this in the sort of second part of the talk quite a lot. So why is it you'd want to actually explain the models of your predictions? Well, one thing is you want to really build up trust amongst the stakeholders who are going to use this model, that the model actually behaves in the correct way. And obviously with sort of very complex deep neural networks, you can't just sort of look at the model. It's got sort of several million parameters. You can't tell exactly what it's doing. So you need to give a sort of some humanly understandable explanation for different inputs, or over the whole range of the training data. What is the model really doing, so I can get some sort of intuition and trust that the model's doing it correctly? And that follows on that this allows you to give some sort of auditing and accountability to the model. So you can say, okay, on these different inputs, I understand the model is sort of looking at these particular features. And you can understand better why the model is actually how it's behaving. And this is also important for something which is becoming more popular, is that there's lots of pre-trained models out there now. models that have been trained on huge amounts of data, have been sort of released, and you can just use them and then maybe do some fine tuning on them for your particular use case. But then again, you might want to do some introspection on those models to really understand how they're working for your particular use case, and is it doing the correct things? Are you happy with that? And we'll talk more, obviously more in the second part on auditing and regulation. Obviously, this is key to really understand how your machine learning model is actually behaving when you put it out there for key regulation reasons. So to understand a bit more how explanations work, there's many different ways of actually viewing it. One is the sort of local and versus global aspect. So global would be trying to get an explanation that you're on your whole training data. Roughly, what is the model doing on the training data? What features is it looking at, and how is it actually behaving in that respect? Whereas local is for this one particular input that produced one output, how is the model behaving just on this particular input, and why did it make the actual prediction it did? The stuff we do at Seldon is mostly more in the local aspect. So we get when we get a particular prediction for a model that either for the customer or the actual team that's actually using the model wants to know why the model behaves in a particular way. Either the data scientist or some other stakeholder needs to understand it, and then they use a local explanation technique to really understand why the model is behaving in that way. So other aspects that are key to explanations are whether it's a black box or white box. The black box means that you have an explanation technique that doesn't need to understand how the model was trained. So it could be a neural network, it could be just a standard regression model, it doesn't matter. It's going to just treat it as a black box, just look at the inputs and the outputs and try to build up a sort of way to explain that model just by using inputs and outputs. And I'll talk a bit more about that. Whereas white box, you actually allow the explaining algorithm itself to actually see the model, look at its weights, look at other aspects of the model completely in a transparent way. Obviously, there's pros and cons. With black box, it means you can apply it to any technique, doesn't matter. Whereas white box obviously has the advantage that if it's particular, say, TensorFlow model, and it's a white box model explainer for a TensorFlow model, you can get certain advantages for that. So it's pros and cons, different reasons to use black box and white box. Then normally there's completely different explanation techniques for classification, regression, and structure prediction. So you need different techniques that work on these different aspects. And also, again, similar to sort of drift and outlier, it's also dependent on the input type. So there's explainers that work best for tabular, images, and text. So again, it's not just a one shot that's going to work for everything. And here down the bottom, you see different types of explanation techniques here. So one quite popular technique is SHAP. This is a feature attribution technique. So it's saying, okay, for this input, it looks like the model was using age to really push it to the reason it gave the sort of classification it did, but the sex, female, was maybe pushing in the other direction, and age was a bit more powerful in the reason it actually gave the prediction it did, and these other features here are slightly less. So you get a feeling of which features the model is honing in on for its output, and it could be quite useful for data scientists to use this technique to say, okay, I'm understanding which features the model is really looking at. There's other techniques like counterfactuals. Here is where you're saying, okay, I've got this, say, classification, the input was 7, and you want to understand, okay, what does I need to change in this input for it to get turned so it's going to be classified as a 9, say. So it's going to look at what is the smallest amount of changes I can turn the 7 into a 9. As this can be used for many different ways. So you could have, not just for image data, it could be for, say, like a loan prediction. You've been sort of denied your loan as a customer. What I want is the counterfactual to say, okay, what do I need to change in my input so this loan prediction is actually going to, this loan application is actually going to be agreed upon rather than denied. So what's the smallest amount of changes I need to do? So counterfactuals is definitely a good technique for sort of customer facing explanations, because it gives them a very intuitive way of what they need to change in the input that was sent to the model, sent to this automated system, to then change this automated system to give a different result in the smallest amount of way. This is another technique called influential training instances, where you have the input. So it was a prediction of a dog, and what it's going to say is, what were the training data that this model saw when it was being trained that made it really was the reasons it was predicting this particular image as a dog. And you see, obviously, there are other images from the training set which are very similar to this, and you can say, well, that's the reason that for this image it's predicting as a dog. And it gives you some insight into the training examples. And obviously, if it gives the incorrect prediction, you can see training examples that were pushing it to the incorrect prediction. And therefore, that really helps in terms of getting more data in particular areas you might want to relabel to really help the model to produce better predictions in certain areas. So as you see, there's quite a lot of different ways to actually handle explanations. So just going into a little bit more detail in how they actually work. So again, if you deploy the model, it's taking, this is like a loan prediction model. It's taking some inputs on age, occupation, postcode, etc., and then gives a prediction of whether it's going to deny or accept this loan application. So that's running. That's great. You push that out using some of the techniques we just discussed previously. And then if you want to run it and explain it in a black box manner on this model, normally what you do is you then deploy the model. You've got that running, and you deploy the black box explainer. And the way this works is, so this is like a sort of image model, and it's going to predict, say, this image is of a Persian cat. That's great. You want to say, why did this model predict it was a Persian cat? The way black box explainers work is normally what they would do is they would change small areas of this image in different ways and keep sending those slightly changed images to the model and see what it outputs. Is it still predicting a Persian cat, or is it going to be predicting something else? So we keep changing and sort of modifying parts of this image, probably calling it thousands of times, which is why, again, explainers are not always fast to actually return their results. They need a certain amount of time. So depending on the input image to really build up some confidence as to why it's understanding how the model is behaving, because in black box, all it can do is look at the inputs and the outputs. But it does this thousands of times, and eventually it comes to the opinion that really it's this part of the image with the eyes and maybe the whiskers that's really the reason the model is predicting it as a Persian cat, as opposed to some other type of cat or some other type of animal. And obviously that gives you quite a nice intuition of what the model is looking at. Again, you can go back to your training data and say, okay, this looks like reasons for this, and use other explanation techniques to dive further on this. So yeah, we have a open source library, LFAI Explain, that has state-of-the-art techniques from some of the things we discussed, like counterfactuals and anchors, which is the one I just showed on the previous page. It handles, again, different types of data. Again, you need to choose your explanation algorithm based on your external stakeholder, so data scientists or DevOps or the actual customer, and on the type of the actual input data that you're going to be sending to the model. Is it, do you want to run a black box model or a white box? Do you want to have local explanations or global, global of the entire training set? What type of model is it? A classification model, regression, and what is the input type of the data? And sometimes you also need to know whether you have access to the training data, because sometimes you might want to have model explainers that don't have access to the training data for various reasons. You want to keep them quite separated out from the people that train the model, maybe for regulations or other aspects, or maybe just complexity of getting at the actual training data. So there's a lot of, again, it's, I suppose what I'm saying today is there's a lot of different choices that have to be made. As part of what we work at, trying to do at Seldon is to try and help our customers get the right choices for the actual models they're actually putting out into production. So just on the final slide of this part of the talk, so how does this all come together? So this is a sort of view of how you'd deploy on a cloud native infrastructure. So you have your Kubernetes cluster, which is managing thousands of compute nodes. You deploying your model using some core library like our Seldon Core or KF Serving, which is the two open source libraries that we work on. You might add an explainer to actual running models, so you can do explanations for that. You're exposing it via some particular API, REST or gRPC, and you probably have a sidecar or sidecar container next to your model that's going to take those inputs and outputs from your model and your explainer and push them onwards. So in what we do, we push them out as cloud events, which is like a standard protocol for sending payloads as events, and then you can have further on downstream components that then run to do outlier detection, adversarial detection, drift detection. And from those outputs, you can push on further to alerting. So all using standards like cloud events that could go to various alerting systems, maybe from drift detection to retrain, maybe outlier detection to label it. So, okay, you better not use this. For adversarial detection, again, maybe send out an alert that your model is being attacked for various reasons. And that's pretty much sort of how it all really ties in, using some of those sort of cloud native libraries, such as Knative for eventing, etc., to really bring it in. And this all really allows you to scale up to really very high levels. So obviously, this has been a very fast run through of how machine learning deployment works, and some of these sort of aspects you need to look at a sort of key sort of technological level when you're actually deciding to deploy machine learning models. And hopefully I've shown you that there's quite a lot of things you need to cover. It's not as simple as it seems, and there's quite a lot of in-depth aspects that need to be really covered to put these out successfully in production. So from there, I think I'm going to hand over to my colleagues. That's giving you a sort of technological background to machine learning deployment. And now we're going to look at some of the wider aspects of deploying models.
Awesome. Yeah, thank you very much, Clive. And I think what we'll do now, we'll take the sort of core foundational technology intuition that we built from the first part of the talk and see how it applies to that higher level societal aspect, industrial aspect, national related type of level. So one of the things that we can all agree on is that critical infrastructure is growingly dependent on not just machine learning systems, but systems that are of the deep tech or emerging technology type. However, regardless of the number of abstractions, whether it's software, hardware, or process abstractions, the impact will always be human at an individual and societal level, right? So, and that is something that regardless of how many new shiny technologies appear, it will always be the case that the challenge and the problem is a human problem. So with that perspective, we do tend to see often what would be high profile type of challenges, particularly in the machine learning space, whether it is due to the continuous, perhaps adversarial interaction between urgency and best practice. However, one of the things that is critical is that when it comes to proportionate impact within other individuals that could perhaps be even across more than one generation impact. You know, we saw some examples with credit scoring and other potential use cases that could actually affect other people. It's important to ensure that the trade-off is proportionate to the use case, right? Making sure that you're not going through completely crazy amount of process when developing a small prototype in your local machine for a specific model, but also not going through the same free range that you would when productionizing a component. From that perspective, machine learning, no different to other software, will be also at the midst of some of the challenges that you find with other systems, such as cybersecurity attacks, software outages, misuse of personal data, algorithmic bias. You know, ultimately, as you saw with machine learning, the machine learning model itself learns from the data that is provided, data that is often created by other humans. And from that perspective, it is always important to remember that the impact of a bad solution can be worse than no solution at all. And remember this note because this is actually one of the keynotes that we will be sort of like wrapping up on. And from what I mentioned, the perspective of machine learning and the whole life cycle involved to create these capabilities involves the responsibility structure that needs to be involved, not just on an individual level, but from a team and department level. And these are specifically not just on how you can leverage the tools that Clive was talking about, such as explainability, adversarial robustness, but also about how you can make sure that the right touch points are in place to understand what are the domain experts, both technical and non-technical, that need to be consulted for in order to ensure that the right best practices are being used. On an individual practitioner level is the technology best practices, the tools that we touched upon earlier, the competency in the field, the professional responsibility frameworks. From the team perspective is the cross-functional skill set, the diversity involved across the team itself, the accountability structure that is placed throughout, and the departmental and organizational higher level principles involved, which we're going to be talking about. When it comes to the professional responsibility, it's important to mention that a single person being ethical and responsible doesn't mean that the group and the organization as a whole will be, right? It also doesn't mean that the software itself will end up always just following those same sort of principles once it's being used and deployed. And the way that I like to see this is with these multiple quadrants, where there may be people that may be ethical or unethical, that may be empowered to do good or not empowered to do good, not know exactly how to do it. So people that want to do good and know how to would be on this quadrant. You know, it's important that we make sure that the people that want to do good, but maybe don't know how to, we have seen certain situations where perhaps there is the right motivations or the right sort of approach, but ultimately because the best practice may not have been used, the outcome may not be optimal. And a lot of the tech companies, when you see a high profile incident, you know, it's not like they are all sitting there wanting to build a racist model, right? That's not their plan. That's not their part of the sprint, right? Ultimately, this may come from suboptimal circumstances. So that's why it's important to empower that both the individuals and the teams can be brought into through the tools, as Clive mentioned, the foundations, the processes that ensure best practices. Also for the unethical and empowered, making sure that the right structures, frameworks are in place to be able to mitigate the potential existence of bad players in the systems. And as practitioners, we have a growing responsibility to our craft, especially as we have seen how larger pieces of infrastructure are depending on the systems. It is important that we're able to also be conscious of the impact of these pieces. And this goes beyond the algorithms. As Clive mentioned, these techniques themselves require also the domain expertise in order to be able to interpret them, but also require to be as part of the end-to-end process with the right touch points to be able to actually take an effect. In that perspective, these large ethical challenges cannot fall on the shoulders of a single data scientist or a single computer scientist, right? These are challenges that require not just the programming and software engineering expertise, but also the machine learning expertise, the policy expertise, domain expertise, that then all intersect towards ensuring the right solution for the right problem. Now, the end-to-end approach doesn't just require, as we have seen a lot of times, those higher level principles, right? Principles in themselves are useless if you don't have the foundations to be able to ensure that they're enforced and to ensure that they're actually implemented. From that perspective, that requires going a level deeper, identifying what are the organizational, industry, or perhaps even national policies, regulations that need to be followed to be able to account and align for that. A good example is GDPR, providing that privacy protection and then extending into how you can then start mapping some of the tools that Clive was mentioning, like explainability, to understand what is the sort of type of data sets that are involved without having to, perhaps have full access to the entire data set, and broader across other different approaches. And then ultimately, as the foundation, the software that aligns with those higher level principles. You may have heard about the concept of privacy by design, making sure that the underlying software is designed in a way such that it can respect privacy in certain occasions or certain scopes. It is important that it adopts all of those higher level principles. And if the underlying core software is not compatible with those requirements on the higher level, it's going to be, it doesn't matter how many round tables you have to agree that discrimination is bad, right? That's not going to be ultimately achieved. And from the terminology, we tend to see a lot of these higher level concepts like ethics and principles, but there is the question of why, should we be adopting some of those key components? Ultimately, ethics are more principles that govern behavior. Principles are foundational truths that you can adopt. And then the question of why don't you just follow existing rules, and why do we have to look at this sort of like core foundations, is because as technologists, we are going to be running across situations and contexts through our day-to-day lives, our work, that may not be written in stone, that will not just have a very simple instruction set that we'll be able to just follow. And that's why basing ourselves into some of those core foundational knowledge is what allows us to really have that Northern Star, to be able to have that collaboration within the teams. Then there's also the question, the higher level question of whose ethics, right? Are we talking about Western ethics, Eastern ethics? But the key thing is that there's not an answer of these are the right, 4 things that you will do and you will forever be writing good software, right? That doesn't really exist. From that perspective, it is important to understand that the value of understanding these foundational core Northern Stars is because software now is growingly built by a more and more global network, right? Currently, especially open source is something that brings in collaboration from multiple different continents, multiple different areas. And from that perspective, being able to understand all of these different components allows for deeper empathy that provides further understanding that may otherwise just be superficial. So you basically just know where the other people are coming from, especially from all of them perhaps even wanting the best for the project or the best for that particular use case. So that's why it's important to really be able to understand all of those core components. And there are a lot of resources to be able to make use. So the ACM, for example, published their principle for responsible development. So that in itself, it is their code for professional responsibility and ethics. And computer scientists would be able to actually look at those and adopt those. And the key thing is a lot of organizations may be saying, well, actually adopting some of these things, may not be good for business, as perhaps they may introduce either too much red tape, or they may not be optimizing for the same things that, perhaps a capitalistic society may optimize towards. But when you read these things, such as contribute to society and, human well-being, strive to achieve high quality, maintain high standards, non-respect rules. I mean, no one could stand here and argue that these things are not going to ensure better quality of a project completeness, right? To a certain extent, this does introduce better quality. And from what we have seen, even, for example, in the UK, the adoption of what was initial, best practices and principles, which, in turn was with the railway sector, with introduction of unions, was to ensure a baseline safety for, across many, many other things. But one of those things was baseline safety and best practices within the workplace to ensure that there's a reduction of accidents. And that resulted in more efficient ultimate work, right? Who would have known that, having employees getting hurt is bad for business? Well, that is obvious, and following best practices can only actually help on those. There's a broad range of multiple different principles that every single company right now is publishing their own, and it may be really hard to navigate. But one of the things that we have been able to identify by mapping a broad range of different principles that are available out there, we have identified some of the principles that have been adopted the most. On a national level, there's been a broad range of countries that have adopted the OEDC principles. But, of course, we are not nations, we are not governments, we are individuals, practitioners. One of the things that we did is we worked with the Linux Foundation to publish what is now the Principles for Trusted AI. These are the 8 LFAI principles, which go through the acronym REPEATS, and this includes reproducibility, robustness, equitability, privacy, explainability, accountability, transparency, and security. And this basically focuses on principles that can be adopted by open source and even closed source project maintainers, by practitioners that are developing software, to be able to understand how they can identify the best practices when really building human software or software for humans, right? And machine learning for humans, right? This really is ultimately on production systems that will be deployed, and these are the expected requirements that provide that Northern Star to be able to be aligned. And we recommend to check it out, and these are all sort of open working groups that can be also getting involved. There's also industry and code standards. Ultimately, the industry standards themselves that we may hear a lot about, these are actually set by volunteers. Well, a lot of them are set by volunteers working in working groups, similar to how open source organizes itself, right? For example, the IEEE has their own sort of working groups that focus on industry standards for AI, such as explainability and transparency. These are the P7000. I think 7003 is the one that focuses on explainability. If you want to get involved, if you think the current tools for explainability are terrible or privacy, you can actually make a change, right? You can get involved. And these are principles that and standards that are set for you, by you, right? And of course, they are potentially then adopted by industries they are otherwise just useless pieces of paper, or now, bytes that are not going to be worth it until actually players in the market actually start implementing them. Again, as I mentioned, there are multiple different organizations, but even also with open source code, for example, the C++ in itself is published as a standard. The language specification is published as a standard. So all of these different areas can be different ways of collaborating towards contributing into best practices that are in a standardized perspective. So I myself contribute to the IEEE P7003, which is a standard for explainability. And then the last part of the equation, so there's principles, there's policies, but now is the important foundation, the software. And the key thing to mention here is that this is the perspective that requires adopting the principles by design. If the core software doesn't allow and is not designed to be able to comply with those requirements, explainability, privacy, security, then it doesn't matter. It's not going to be achieved. And that's why it's important to have that open source as foundation, primarily because now open source is becoming, or has become, the backbone for society, right? Both in machine learning, you have projects like TensorFlow, like PyTorch, which are used in pretty much large percentage of the use cases that you would see. It's very few now to just have like a very specific proprietary closed source library that wouldn't be using already something like this as foundation. So it is important to ensure that all of those things are built with that in mind. And the exciting thing is that organizations like the Linux Foundation, which basically maintain the Linux kernel, the Linux in itself and a lot of the other components, and especially also other things like Kubernetes, etc. These organizations are adopting this by design, which is very cool. Now then it's taking it in the same approach and taking open source as policy, right? Not just as foundation, perhaps having programmatic governance by having the open source and the software itself align with those policies and principles that need to be accounted for. And then taking it to the next step and making sure that there is an awareness that the people writing the code, that the people involved in the code, product managers, project managers, domain experts, community managers, all of them are equally critical to the development and success for this, and hence need to be involved when it comes to the interaction to set all of those components. So they need to be part of these discussions, and we ourselves need to be involved and need to want to be involved in these discussions, because they have an impact and they really set the future. Now, it is interesting, and you can't really see this, it's very tiny, but these are just screenshots of some open source projects, including TensorFlow, PyTorch, the two open source machine learning libraries that I mentioned. Clive mentioned a couple more, Alibi, Seldon Core, but then there are others like Tencent's WePy, or NCNN, which is a neural network library, or Alibaba's I think is MNN, which is another machine learning library for mobile devices. The reason why I'm putting this here is because the traction that each of these libraries have, like the Tencent ones, has like 25,000 stars, which it's a vanity metric. But from that perspective, this reflects back into what I was saying on the higher level principles, the Eastern ethics, Western ethics. Of course, I'm not saying that these open source projects are like guided by like foundational Socrates principles versus Confucius principles. Of course not. But from that perspective, the contribution and collaboration of this type of projects that are really driving the core foundation of our societies from the technological core infrastructure, it is important to ensure that there is that mutual collaboration, global collaboration that requires a global empathy, a global understanding to be able to really contribute and collaborate towards sort of that unified higher level type of principles. So I just wanted to mention this, that is an interesting piece. And there is enough for you to get involved if you're curious. Us ourselves at Seldon and at the Institute for Ethical AI, we have a bunch of open source projects that we would love for you to get involved with. If you have never contributed to open source, we are also more than happy to help you out. There is instructions in the Seldon Core repo to get involved on the Slack community. So if anything, just reading the documentation, improving the documentation is a massive contribution. And you contribute to open source by using the tools. So I think that's the key sort of foundation of that. And actually, that I had already like a slide of that. So if you actually want to get involved on open source, please just check out the repo on Seldon Core. You can open an issue. If you're not going to be using Seldon Core, then there's a broad range of other different projects that you can also check out. And of course, something that we haven't delved into is the side note of regulation. I did mention GDPR, but it is still worth mentioning the sort of contrast when it comes to this. And there may be a lot of different points when it comes to regulation. A lot of the perspectives may be saying, well, regulation is bad because it's going to hinder innovation. Regulation is bad because it's going to introduce a crazy amount of red tape. But I think the one thing that I always tend to mention is that we can all agree that bad regulation is bad, right? When there's not going to be suitable applicability, it's just going to end up with a lot of loopholes, together with a lot of which bad players can exploit, as well as a lot of red tape that is going to hinder the positive players that are bringing innovation. However, good regulation, as we saw with the previous example that I was mentioning in regards to the railway sector, can be a catalyst for innovation through enforcement of best practice and mitigation of bad actors, right? Making sure that we don't end up with some sort of like small players like exploiting an entire financial loophole, causing a global crisis, right? But also ensuring that the best practices are also enforced, so that we don't end up with like 1,000 different small startups that say that they have like an amazing AI-based technology, but all they have is a nice PowerPoint, and they end up with like a lot of large organizations with terrible solutions, right? And this is bad for everyone, right? This is bad for everyone. So that's why it's important to ensure that there is best practices from the area. If you're interested in regards to the ecosystem around policy, especially around AI, we actually curate a repository with a broad range of different sort of like regulatory policies and pointers that are actually very interesting to read, especially to see how each nation approaches their data strategies, and then how that becomes potentially regulation or standards. So you can check it out. It's called Awesome AI Guidelines. And again, it's open source. If you don't want to contribute to the code, you can contribute with links on this, which is quite exciting. And with that, I think there's, we don't need to convince anyone that software and AI has massive traction, and it's only going to grow, especially when it comes to the use cases and the impact in our lives. But it is important that when it comes to more specialized tools like AI, is that not everything can be solved with AI, right? And it is the case that when you're running with a hammer, everything may look like a nail. From that perspective, what we have been able to do when it comes to Seldon Core itself, it specializes specifically on deployment of machine learning, explainability of models, right? But when it comes to the entire end-to-end process, it is important that not the end-to-end has to be automated, but there needs to be a human in the loop. There needs to be an involvement of domain experts. There needs to be a specific set of touch points that mimic what would be required in the non-technological application when it comes to human interaction. And with that, I guess to just wrap up and to kind of mention and refer back to the point that I had in the beginning, is ensuring the right solution for the right problems, right? So before tackling a problem, we should identify how much of it is a software problem, how much of it is an AI problem, and how much of it is a human problem, and then be able to have a proportionate hybrid of a solution that addresses for all of these challenges while taking into consideration the proportionate risk and the impact that it can have in its ultimate users by following the right level of transparency, explainability that is required for that use case. And only success can be achieved when the right parties and the cross-functional, diverse individuals can be involved. Of course, not in every single use case, not when building a prototype, but that is proportionate to the risk. And with that said, I think that is a lot of content. We've covered the entire spectrum, so I'll just pause there and pass it over to the organizers to see if there are any thoughts or questions. Yeah. And also feel free to write down the thoughts or questions on the chat as well.
Yeah, sorry to be a bit slow in coming back. My computer was playing up a little bit. Yes, if you'd like to put your questions into the chat box, as is our normal custom. In fact, I've asked Steve if he will collate the questions and forward and ask them to you.
So
Yes.
far, nothing here. Oh, here we go. Oh, just a thank.
Always nice to have thanks.
Yeah, I think we covered quite a lot, so probably still processing.
Blowing people's minds.
Yeah.
Does
Either
it
that
run
or
on?
they all fell asleep. Yeah, we can't tell online. Yeah.
Will it run on Raspberry Pi? Can you do a cluster on a Pi?
Well, the answer is yes. We
Yes.
actually have a talk online where one of our machine learning engineers has a demo showing a face mask detector running on a Raspberry Pi using, I think it's not micro Kubernetes, it's KubeEdge, something like that. But yes, it does. We've proved it.
Hi, hope everyone can hear me okay. I'm sure everyone agree that that was an absolutely brilliant session. Colin and obviously Steve and Keith and everyone else, if we want to facilitate, sorry about that, I'll come over here. Yeah, so, right. Sorry about that. Yeah, I think that was an absolutely brilliant session, very valuable. Just wanted to thank Alejandro and Clive for their time and for doing that. And if anybody wants to ask any questions on the chat, and obviously I just wanted to thank everyone again for the time. It's deeply appreciated.
Thank you all.
Does anybody have any specific questions at this point, or would they prefer to use the forum or take them offline?
No, I think our speakers have actually wowed them into silence. Oh no, here there is a question. Go on, Steve.
Hold on. Ethical question. People talk of loneliness being the next pandemic. Would you consider AI companions an ethical solution? I've seen some arbitrary ones out already, but personally, they seem sketchy to me. And that's from Leslie.
Yeah, I mean, I can give some initial thoughts. So that's a great question. And what is interesting is that actually loneliness has been raised as a pandemic and as a massive risk even before the current pandemic came in. And ultimately, the solutions that have been coming up, I agree, has been largely on AI companions. But there has also been some interesting and very high potential solutions that have come with just connecting humans to humans. So from that perspective, I would say two things. The first one is that when it comes to the ethical considerations of AI companions, particularly in the areas of mental health, there are big requirements that need to be in place, including the transparency that is necessary to ensure the awareness that people are actually speaking with not a human. So that's on the first part. The second is to ensure that the actual practice in which it's being used is approved by the constraints that are necessary when it comes to any non-AI solution that involves treating mental health, right? And when it comes to non-technological solutions that involve that, do have some constraints and some certifications that it has to go through even before it can be used. Now, for the second part, which is on the ethical considerations, is making sure that also not just the interaction is considered, but also the data that is being stored, the people that are in the other side, making sure that they're over age, that they're the people that are curating the messages are also in place. So there's quite a lot of things to consider, and I do agree that a lot of the arbitrary ones that may come up will be pretty sketchy. I think back to the point that I was saying is that when it comes to AI solutions, especially ones that may have big impact on humans, need to have the right level of human, and may even have the question of, should you really be introducing an AI into that? There has, however, been some really interesting trends in Southeast Asia, actually, with purely AI solutions for like chats and videos that have been just growing massively. So this is something that will probably also be a trend, and there will have to be some management that we'll have to do as practitioners to introduce the right safeguards. So it really is going to be a question that will have to be continuously answered. So that's really interesting, very interesting question.
No, thank you. That was interesting.
Alejandro, can I ask you a quick follow-up on the back of that, if I may? Obviously, you don't need me to tell you that there is such a thing as good AI and bad AI. And in terms of raising the bar across the board, would any kind of governance or regulatory compliance, would that add any value to improve the integrity, the usage and application of the AI technology that you described?
Oh, 100%. And I think for this, I'll answer one part, but I think it would be, we also if Clive covers the technological aspect, because similar to how there's crappy software, there's also crappy AI, right?
Is that your professional opinion?
No, yeah, and this is the technical term, right? But ultimately, the main thing to mention is that there's no such thing as ethical AI and unethical AI, right? AI is a hammer, right? It's a tool, and the tool in itself can be built and used with best practices or not best practices, and it may be fit for the use case or not fit for the use case, right? And this is where the whole host of questions come in from the governance. Yes, of course, it's important to ensure that the actual loopholes and bad actors are mitigated, but then from a technological aspect, that's equally important, and that's pretty much all of the areas that Clive covered. So I don't know if Clive, you have some thoughts on the sort of infrastructure.
Yeah, I think we just have to give people the tools so that they can put AI out and have the appropriate monitoring and explainability, so the appropriate checks on that. But I think in general, it's going to be a general dialogue we have in society. So I mean, in more general, I think it comes back to things like this at bigger and smaller levels. Everyone just has to keep talking about it as new applications of AI come out.
Okay,
we just need to discuss it. Loaded
question, Clive. Some of us of my generation remember things like the British Lion Mark, for example. Now, is there an existing industry accreditation or benchmarking for AI? If there isn't, would AI across the board stand to benefit from that? And organizations such as the BCS, if there was to be some kind of accreditation, some kind of benchmarking, some kind of lion mark to help raise the bar, would that add any value in terms of everything that Alessandro and yourself have just touched on, please?
Well, I think it comes back to what Alejandro is saying. There's many organizations like the LFAI putting out best practice, and obviously if organizations follow that best practice, that's going to make a difference. But yeah, I don't see it as simple as just, but we shouldn't hide behind just because you have a mark there that solves everything. I mean, I think this is why it's going to be as I say, a continuous dialogue in society, because once you have a mark there, then the people just will switch off. And that's going to be just as bad. So, I mean, we have to help people with LFAI standards and that's coming out of different areas, but we just need to have a constant dialogue, and it has to be at all levels. So it has to be at the parliamentary AI group, which our CEO is on. We have to be at the BCS, it has to be at every level. We just need to not stop talking about it, basically. As AI becomes more a part of our society, we just need to keep investigating it, discussing it. Is it good for us? And just decide as we go forward.
And from my part, I appreciate everything that your organisation has done, has helped to raise the bar, and the contribution that you've made to the APPG as thought leaders. Again, speaking for myself, has been invaluable, and it's appreciated by those of us that want the real substantive value in AI, and the bad actors with vaporware, which are doing harm to all of us every single day. And so it's deeply appreciate everything you guys are doing.
Well, thank you very much. We really appreciate it. Yeah.
Colin and Keith and everyone, do we have anybody else wanting to do any questions?
No, I'm not seeing any. Steve looking after.
I'll do a quick one. Is it really AI? As my bugbear.
Is what really AI?
Any of this? There's no intelligence there really.
I guess we can go into that philosophical discussion, but that's not going to finish in the next 2 hours.
You're like a fan of the Seld's Chinese room, Steve?
Of the?
Have you not heard of Seld's Chinese room? It was like very popular in the 1980s. Seld was like a philosopher saying that, you know, AI is pretty much just like a room where you feed in stuff and it comes out the other side, but there's no intelligence there. It's all just like someone looking up some symbol and pushing out the other door. I thought you might be referring to that. It caused a bit of a stir in the sort of AI community during the time I was doing my PhD.
The problem with artificial intelligence is we don't actually have a definition of intelligence anyway.
I was just going to say that there's no objective universal definition for the term. Hence, it's all the conjecture and all the debate, isn't it?
So it's a meaningless question ultimately, for the moment, anyway.
Yeah, I mean, I wouldn't get too bogged down on it, really. I mean, we need to look at what these things are doing rather than deciding whether they're intelligent or unintelligent. What they're doing, is it good or bad? Is it useful or is it not useful? Look at it more just on that level. I think it's more appropriate.
A little similar to the standard answer to quantum mechanics, which is called the Copenhagen method.
So just calculate.
Shut up and calculate. Yes.
Fermat's last theorem. Everyone's going to talk about it for the next 400 years, and no one's going to solve it.
Yeah.
Does anybody else have any questions? Well, we've got two incredibly talented, well-qualified people at our beck and call.
We got an interesting response from Leslie, which I'll take his opinion on it and agree.
Steve or anybody, do we have anybody else in the chat with any other questions we can answer?
I've got one last question. Do you believe AI to be the gateway to the singularity? If you believe in singularity.
What a question.
No, absolutely no. It's just a shinier hammer.
I like that. Thank you.
That is rather a good exit line, actually.
I don't think you're going to get better than that.
No, that was good. Thank you very much.
So on behalf of everyone on the committee, I just wanted to thank, firstly, Steve and Alejandro for their time.
There's a quick question here from Carol. Well, there's one is, did Alessandro create his own background? It's very cool. But I guess that's a Seldon logo. And what would the experts, Carol asks, what would the expert ask users to understand before commissioning an AI project?
Well, so the background, actually, that's a great question. Actually, my partner made it in 3D Blender. So that's really cool. I'll mention that the background was complemented. So that's really nice. Thank you for that. And the question of what would the expert ask users to understand before commissioning an AI project? I mean, this really is very similar to what would be in regards to commissioning a software project. And the question of what would the expert ask and who the experts should be is very much proportionate to the use case and the scope of what is being achieved. And I know that's a very non-answer type of answer, but I guess it's
I suppose it goes back to one of your slides, Alejandro, is that you need to decide whether AI is really the solution for this, that there's many simpler things that you can do. That's where you don't want to get on the bandwagon. You know, if you can solve it via other means that are more simple for the organization to run, then you definitely would. That's the biggest risk, is just jumping on the bandwagon and applying AI to things which you haven't got enough data, or it's just not worth it. So yeah, you definitely need to be careful. to take AI where it's really, really needed. Or machine
Yeah.
learning, I should say, rather than AI. Yeah, it's probably more appropriate.
Yeah, I completely agree. Yeah, it's like what's the question is what's the data? Do you have the right distribution? Yeah, it's very much.
And you only need a lot of data before machine learning actually makes a difference. So, and if you've got a few thousand data points, then there's probably a better way to do what you want to do.
At least until Skynet comes online and decides it's better off without us anyway.
Yeah, well, that'll be all over then, so we can be too late.
So, gentlemen, if there's no further questions, I wanted to deeply appreciate and offer thanks to Clive and to Alejandro. I hope this is the first of many such opportunities for them to come and speak to us. I personally learned one hell of a lot, and I deeply appreciate it. And you've got an open invitation from all of us on the committee to come back another day. If you want to bring any of your colleagues, by all means. Please thank, obviously, your CEO for the work he's done in advising the government. Government can't get enough advice. That's all I'll say on that issue before I get myself in trouble. And again, deeply appreciate everyone's time this evening. I hope everybody got something out of it. Any thoughts and feedback is appreciated, and we hope to see you all another day. And stay safe and keep well.
Thanks, really appreciate it. Had some great questions, and really enjoyed ourselves.
Everyone keep safe and well, please.
Thank you.
Can we put the slides up somewhere? Sorry, before everyone goes.
Yeah, definitely.
Live or
we'll sort that out. Definitely.
We'll send them to you and Paul, and then those can be circulated.
Yeah, I believe they come out to all registered attendees anyway, but I have to double check that. But again, we hope to see everybody next time. Deeply appreciate everything, and stay safe.
Thank you.
Okay. Bye.
Bye.